All right, so number one is pretty straightforward. How did you guys do problem number one?
A equals 2 pi. A equals pi r squared.
Right, area of a circle is pi r squared. Okay, so of course that means we're going to do pi times 3/8 squared. You didn't really need a calculator to square 3/8, did you? Because what's 3 squared?
9.
3 squared is 9. What's 8 squared?
64.
Okay, so you don't need a calculator for that. So 9 over 64, and then don't forget your pi. Okay, so the area of the circle is 9 pi over 64. So that is the answer. So if I ask you for exact, that's what you would give me. Also, I want the exact answer, the decimal answer as well. 0.44. Any questions about problem number one? Okay. You can either write it on the top, or you can write it off to the side in the middle. Either way is fine. If you wrote 9 over 64 and then pi, that's equivalent. All right, I'm going to skip over number 2 for a second. Come back to that. Number 2 is one level higher. We'll come back to it. Let's go ahead and do 3 and 4 first. When you see a sector like this, a sector problem, what's the formula that I'm probably going to wind up using? Who said that? Part over whole equals part over whole. That's what we do when we see that it's part of a circle. That's what we did when we had arc length. That's what we're going to do when we have a slice, a sector. So everyone should be thinking part over whole equals part over whole. Now, we know we're going to do part over whole. Before I even set this up, we know we're going to need the whole area in a second. Okay? So we're given this radius. How could I find the area of the circle? Yeah, square it. All right? One more time. We're doing pi r squared gives us the area of the circle. So this is going to be squaring that 8 is going to give us 64 pi. Okay? Keep that in mind. That's the whole circle. All right, so Siobhan, what do I usually put on this fraction? On the right-hand side. Yeah, 60 over 360. Okay, that's part over whole degrees. Okay? Help me set up the left fraction. X over 64 pi. That's the partial area, which we don't know, divided by the whole area, which we just found. And then reduce the fraction, I hear you saying? It's 1 over 6. Okay, x over. She said cross multiply. So if I cross multiply, tell me what to write. 6x equals 64 pi. And then simply divide by 6. Wait, give me the reduced exact form first. I'm betting it's going to be 32 over 3. I'm reducing, okay? Look at 64 over 6. Do you see how they're both divisible by 2?
Yeah.
We definitely want to reduce that for the exact version of the answer, okay? So this would be the exact version of the answer, 32 pi over 3. And I believe you were about to give me the decimal version.
30, well, it's 10.7 pi, but then you're not supposed to do that, so it's
93.6?
33.
33.6. Okay, any questions about number 3? Okay. Patrick, you've been absent. How much of that did you understand? You got that? Okay. Let me pick on you a little bit. since you've been missing out. Look at number 4 with me. Just like we used to do when we did arc length, and we did part over whole equals part over whole, still doing the same thing. So, Patrick, tell me what I'm going to have on this equation on the right side. 120 over 360. Okay, what goes in the top over here probably? X, because we're supposed to find the partial, this time area, partial area, so still part over whole, X over. Now for the whole, in the last unit, this was circumference because we were talking about the edge. Now we're dealing with area, so instead of doing C equals 2 pi r like we used to, for the whole we do, have you picked up what's the formula for the area of a circle? Pi and then r squared, okay? And this is the same thing as 4.5, okay? So if I put that into the formula, this becomes pi times 4.5 squared. Siobhan, for a moment here, could you tell me what 4.5 squared is? Without the pi, just 4.5 squared. 20.25. So this would be 20.25 pi. Now, Siobhan, if this were the final answer, I wouldn't leave it like this, but for now, it's the best we can do. So 20.25 pi. That's the whole area, so I'm going to go ahead and put this in the bottom now. Okay, part over whole equals part over whole. Patrick, what does this reduce to on the right? 1/3. Okay, so I've got 1/3 equals all of this. All right, what do I do now, Patrick? Time to cross multiply. Tell me what to write. Correct. What's the last step, sir? Divide by 3. Now, and this is the point, Siobhan, at which this is as close as I'm going to get to an exact answer, but since it has a decimal in it, I'm definitely going to go ahead and just go with the decimal answer on this one. Okay, so what's the final answer? 6.75? Yeah, 6.7.
You have to divide it by 3, and then you get...
Let's see, 20. Let's put it in the calculator. 20.25 pi. You forgot to put the pi? Okay.
It still equals 25.
Right.
Oh.
21.6?
21.2.
21.2?
Yes, sir.
All right, does everyone agree with the 21.2 answer? Okay. So there we go, 21.2. You getting this, John? You're not even on the right side of the paper, brother. All right, any questions on number 4? Okay. Let's go back to problem number 2. All right, I need to lay the groundwork to bring everybody with me to understand number 2. So study these shapes with me. Everybody focus and look at this. Look at these shapes. This is not on your paper, so everyone should be looking up here. Yeah, put that away right now. Okay, I need to know a relationship between these 3 areas. And I'm just talking about the blue, okay? So I need to know the relationship between this blue area, the heart area, the the square blue area, and the blue part. It's not including the white, but just the blue area. Take 60 seconds. Turn to the person sitting next to you on either side, or even behind you for that matter. See if you can come up with a relationship between these three areas. Go. Okay. What did you guys come up with? Somebody raise your hand and tell me something. Go ahead. I haven't talked to Matt in a while. Go. Okay, which one is 1 and which one is 2 and which one is 3? Okay. He said this one, this is the way he said it. He said this one plus this one would equal that one. Okay? That's one way to think of, that's one correct way to think about it. If I take this, the open heart one, and I add the heart, I'm going to get the square. That's good. That's correct. Anybody have another way to think about it? Haven't talked to Julian today.
Square minus the filled in heart equals square.
Okay. He said another way to look at this. He said if you take the square, I almost have to move this around. Hold on a second. He said if we take the square, oh no, go back.
Did I already see the next slide? Nope, I see the next slide.
That's all right, we're there. It's fine. He said if we do the square and we subtract the heart, come back to me. He said if we do square minus heart, that's going to give us this empty shape right there as well. Stay with me, brother. I know they got you on pain meds and everything, I'm sure. Okay? Now, this is the version that's going to be more useful to us because on problems like this, we're trying to find the outline. We're looking for the shaded area outside. So if we sort of look at it as the whole square minus the heart leaves, like a cookie cutter, taking the heart part away, it's going to leave the outer part. It's solving it for us. So that's the way I want you to look at it. So if I give you an empty shape like this, think of it as the outer shape minus the inner shape. Does that make sense? Okay? Now, if that made sense, then look at this picture. I'm only giving you 30 seconds this time. And decide the equation. I want this type of equation for these shapes. They're in no particular order. Take 30 seconds and talk about it. Come up with a decision. Go. Okay. What did you guys come up with? The triangle minus the moon. If I want this original shape, the triangle moon shape, I could find it by doing triangle minus moon. Okay? So this shape would equal the triangle minus the moon. All right? Hold that in your head. So, here's a problem that's similar to number 2, but the areas have already been, I've made up areas for them. Just to make sure you understand the basic concept. Okay? So, Julian, if the circle has area 100 square inches, the triangle is 75 square inches, what would be the area of the outer shaded part here?
25.
It would be 25. Okay? Why, Maurice? Where is he getting this from?
Sir?
Why?
Oh, because like the 100 minus the 75 equals 25.
Right, we just decided that in a situation like this, with an empty shape that seems like it was cut out like a cookie cutter, that would be the same as doing the outer shape minus the inner shape. So this outer area should be circle minus triangle. In this case, 100 minus 75. Okay? McDonald's. Is this making sense? Okay. That's going to be our strategy for problem number 2. Get rid of this for a second. Okay, so Maurice, if I want to find the shaded area, I'm going to do what minus what?
Circle minus triangle.
Circle minus triangle. So I'm just going to write this down to remind me of my strategy. So in this case, the shaded area should equal the area of the circle minus the area of the triangle. That's my strategy. So let's just do that one at a time. Let's start with a circle. Off to the side, let's find the area of the circle.
It's 64 pi.
Okay, I hear Drew saying the area of the circle is going to be 64 pi. Of course, he's doing pi r squared, because it's a circle. And the radius is 8. Can everybody see that the radius is 8?
No.
Okay, who said that?
Why would it not be like 4?
Okay, look at the red that I drew, and compare that with the blue that I'm about to draw now. Okay? Try to see why the red is the radius, but the blue isn't the radius. Can you explain to me why?
But it's like half.
Right, the blue doesn't get all the way to the edge of the circle, but the red does. Okay? So can everybody see that 8 is going to be the radius? So if we put that into the formula, then that's going to give us our 64 pi. Okay? So that's the area of the circle. Now, let's find the area of the triangle. How do we find the area of a triangle? Julian, any idea? How do I find the area of a triangle? That's close.
Or base.
Base times height, but so far that's a parallelogram or a rectangle. 1/2. Okay? Try to remember this, guys. The formula for the area of a triangle is 1/2 base times height. Okay? It's 1/2 base times height. I put it up there for you if you needed it. Ariel, heads up, brother. Let me stay with Julian for one more second. Sir, what is the base and what is the height? Start with the base. What's the base?
8.
The base is 8 square root of 3. I'm leave myself a lot of space. All right, so the base is 8 radical 3. Maurice, what's the height?
I'm on that one.
What's the height?
Would it be 8 radical 3?
No, that's the base, brother. 8 radical 3 is this. Okay, the height.
Height's 12.
The height is 12. Ashlyn, do you see where he's getting? What's the height of this triangle, Ashlyn? The height. The height of the triangle. What is it?
12.
All right, where are you getting that from? One more time. People, seriously, when I'm talking to one student, y'all be quiet.
Obviously 8 plus 4. Oh, so I'm okay, I see now.
You see it now? Okay,
Yeah.
that's what I'm waiting for. All right. Yeah, the height of the triangle is this blue piece and the red piece put together. It's 8 plus 4. That's going to be 12. Okay. Put this in your calculator. 1/2 8 radical 3 times 12. Just put all that in your calculator right now. Everybody. 1 second. You have the answer for me. All right. Go ahead and ask me while they're typing. Okay, see this 8 radical 3 right here? Okay, you see how it's pointing to the bottom of this triangle. So that 8 radical 3 is telling me that this is the base of the triangle. Tell me when you got it, Ashley.
Argument error.
Yeah, that's what I got.
Yeah.
All right, let's see how you typed it in.
I got 48 radical 3.
1/2 8 radical 3 times 12. Oh, okay.
Oh, I got it. 48 radical 3. Yeah.
You got it? Okay. I won't. Oh. All right, is anybody having trouble coming up with 48 radical 3? Is anybody else getting an error? Some kind of error? Boys, stop playing back there. All right, so let's go back to our strategy. Our strategy was to do circle minus triangle. That was going to give us the shaded outer area. So we found circle. That was going to be 64 pi. And now we're subtracting the triangle. So that's going to be minus 48 radical 3. This should give us the shaded area, circle minus triangle. Now, as far as an exact answer, Siobhan, this is exactly what you would put on your paper for the exact answer. There's no way to subtract these. They're not like terms. But if I wanted a decimal, then of course you would type this entire thing in your calculator. 117.9. All right? Do you understand it? No? All right. Okay. Good. It's hard to hear. Did I lose anybody in that explanation?
Are we done?
We're finished with number 2. All right. We already did 3 and 4. Let's talk about number 5. Can someone give me a strategy for how I would approach number 5? Talk to me, Danielle.
Like 180 from 4 or like.
Right. We're going to need those degrees. They're all congruent. So the top semicircle is 180. So Danielle is saying let's divide by 4, and we got what? 45. Okay, let me change colors for a second. So each one of these little angles is 45 degrees. All right, did I lose anybody so far with the 45 degrees? Now, keep talking to me about your strategy.
And then from there you can do, you can try to find the area, and then you can do A over 25 pi equals 45 over 360.
Right. Okay. So we can find the area of one sector in our usual way. Okay. So I hear you saying, let's find the area of a single sector by doing 45 over 360 and x over,
25 pi.
yes, okay, x over 25 pi. Now one more time, let me be clear where this 25 pi is coming from. We're doing partial area divided by the whole area. The whole area, we are using the formula for area of a circle. We're doing pi r squared. And we're taking our 5 and we're substituting that in for the radius. And that's why we're getting 25 pi. Okay? Whoa. You do not need to show this calculation every single time. If you see the 5 and you want to go straight for the 25 pi, that's fine. I'm just making sure you understand where it's coming from.
Thank you.
Question?
It was,
Kind of simplify.
would it work if you do 45 times 3 and
Sure, you'll get the same thing. Okay? And I'll mention that at the end as well. So what is this fraction that we're going to get? 1/8? Okay, so I've got x over 25 pi. All right, how do I finish off the problem?
Cross
cross multiply, so I'm hearing 8x equals 25 pi. That's going to give me, what am I doing now? Excellent. Ronnie.
25 pi, 5.8.
That's why. Okay, so this is leaving me with x equals 25 pi over 8. Alright, now I know Daniela knows the answer to what I'm about to ask. Everybody listen to me very carefully. Christy, is this the final answer? Are we done?
That is not,
Why is that not the final answer?
because you have to simplify it.
Well, yeah, even if I reduce, it's already reduced, I could make it into a decimal, but that still wouldn't be the final answer.
Oh, you have to put it into a decimal.
Even if I made this into a decimal, that still wouldn't be the final answer.
So we wrote pi.
Siobhan, do you have any idea why we did all that good work? It was all correct. Can you tell me why this is not the answer?
Because you're looking for the entire thing, not just one segment.
So what would I need to do?
You would have to multiply that by 1/8. 7.
That would be too much.
7. Stop.
You're so close.
Oh, just by 4, because you did 180, you only did half of it.
Talk to me, Ronnie.
I was going to say you have to multiply by 3 to get this ratio.
We're finding the area of the shaded region. Okay? So Christy, Siobhan, and everybody listen carefully. I feel like just then half of you knew this already, and you're like, yeah, that's what I was about to do anyway. But then half of you were not understanding. So everybody focus and listen to what Runzel said. Our job was to find the shaded area. So far, we've just been finding the area of one single sector. Okay? How many shaded sectors are there? Runzel is reminding us that there are 3. So we need to take our answer and multiply it by 3. And then that will be.
75 pi.
That is correct. Let me just make some notes on here in case anybody is looking back at these notes later. So please understand that this represents only one sector. Okay? So to get the true answer, we have to take this and we have to multiply it by 3. Okay? Does this make any sense,
Yeah,
Maurice?
75 pi over 8.
Excellent.
29 plus 452.
Ronnie, that's 2. So that's going to be 75 pi over 8.
It's equivalent to 29.452.
Excellent.
29.5. Yeah,
No, it's the same thing.
Okay? Any questions? Did you follow that? All right. Take a minute and do number 6 by yourself. Wait, actually,
Do that with us.
I'm going to give you one hint first. This problem should be easier than the previous problem, except for one thing. Just now, if I had released you to work on this problem, half of you would have started off going 75 over 360. Right. Okay?
Are we sure
I need everybody to understand why 75 over 360 would be wrong. Do you guys understand? We're supposed to find the shaded area. Look where the 75 is.
What about the 11?
Well, that's the radius no matter what, so that's okay. You can't use the 75 because that's the unshaded area. So Siobhan already told us what to do. How do I find the part I really want, Siobhan?
360 minus 75. And you get 1 of the area.
This one's answer is
Let's do from 180. That's what you said the first time. Yeah, so subtract from 180.
180 minus 75.
180 minus 75.
We're going to do 180 divided by 2.
All right, so everybody go ahead and finish problem number 6, but make sure you're using 105. What's up? All right, so real quick. My strategy is going to be to find the area of one sector and then double it because there's two of them. It was pointed out accurately that if you wanted to, you could just double the degrees right now and understand that the shaded area has total degrees of 210. Then you'll get, and you're doubling it in the first place. Either way, I'm going to just find one and then double it. So this would be x over 121 pi
Precisely.
equals 105 over 360.
That's what I got.
Okay. Of course, the 121 is coming from pi times 11 squared. Okay? So that's going to be x over 121 pi. What does this reduce down to? 7 over 24. So that's going to give us 24x equals 847 pi. Dividing both sides by 24.
110.87.
I sure am. Okay? All right, so please remember, this so far is only one sector. All right, Ronnie, remember, you're this close to having detention, so you need to stop mumbling. Yes. What's happening is you're doubling the numerator, but then it's reducing with the 24. Your calculator is just doing all that ahead of time. So, but your answer, what you just said is correct. You should wind up with 847 pi over 12.
Precisely.
Okay? So this is the final answer once we've doubled it. That's the exact form. Can somebody tell me the decimal form?
221.744.
221?
Yes.
Not what I got. I got 110.9.
You didn't double it.
221.7. All right, any questions so far? People in the back, did you get this answer?
Wait.
Yep.
Wait. I plugged it in.
You multiply by 2?
Oh, never mind. I forgot to use square root.
Wait, so did you get this or did you get 400? Over 24. That reduces down to the same thing. All right, I'm going to have to come look at what you did. Stand by, stand by. All right, look at number 7 with me, please. It'll be on Edmodo. Go. All right, look at number 7 with me, please, very carefully. Tell me our strategy for this problem.
You find the area of both, and then you subtract one from the other.
Right. Let's call it, let's think of this as the big circle and then the smaller circle on the inside. So, Ashlyn, to find the shaded area, going to be the same as finding the big area minus the small area. Okay, the big circle minus the small circle. So, off to the side, let's find the area of the big circle. Now, Siobhan, in order to find the area of the big circle, I'm going to need the radius of the big circle. Can you tell me the radius of the big circle? 4 is just from here to here, right? I need to get all the way to the center if I'm going to be the radius. That's closer. Talk to me about this piece right here. Is that 12?
Oh, okay. So 10.
10. All right. Shh. Please hold the talking, people in the back. The diameter of the small circle is 12. That means the radius is 6. Okay, so that's telling us that the radius of the big circle is 10. Okay, that's why the big area is going to be pi times 10 squared. I'm doing pi r squared. So the big circle is 100 pi.
Which turns out to be 350. I missed something.
Now, what about the small circle?
That's 113.
The radius of the small circle is 6. Please make sure you're using 6 and not 12. So the small circle is going to be 36 pi.
And then you subtract the big from the small.
And then you subtract the big from the small. So that's why we're just going to do 100 pi minus 36 pi. Right, please notice we're not going to leave it like this. Ashley and Savant, these are like terms, so we're not going to leave it separate. 100 pi minus 36 pi is 64 pi. Any questions? All right, we'll leave it there.